Hi, I titled my project A Matter of Time because it's not a question of if, but when many of these slopes in Seattle will have landslides. Tonight I'll give you an overview of the Seattle area, its geology, the glaciation that helped shape Seattle, my data and methods, my results, conclusions, and then I'll take some questions if you have any. My Seattle landslide study area is Greater Seattle, including King County, Pierce, and Snohomish County, as well as a small portion of Kitsap County. It was originally settled by the Salish people who were there for thousands of years. The first place that was settled by white people was Alki Point in this area right here, which we'll see a lot of later on. Even though landslides have been recorded since 1890, construction has continued in many dangerous coastal areas. All of Seattle's hills are built on, and the coastal areas especially are very, very vulnerable to landslides, as we'll see. The average rain precipitation amount in Seattle is 37 inches per year. It's highest in the winter. It can be much higher than this, as we saw in the Oso landslide this past March. They experienced 30 inches of rain in the first 21 days in March, when they normally get 6 inches of rain. I kept my study area to my main study area to the Seattle city limits and Bainbridge Island, because my data was limited to those areas. This is a Seattle geology map. The Seattle fault that you can see right in this area here is a northward thrusting fault parallel to the Tacoma Fault. There are several strands to the fault. The sections going across Puget Sound are not entirely known and fairly controversial, because there's a lot of discussion going on about where they're actually located. And geologists actually thought that the Seattle Fault was inactive as late as 1980, but studies since then have shown that it's very active. The main unit you'll see here is this reddish brown. This is glacial till, which was formed during the Fraser glaciation. The yellows are moraines and sands, which are outwashed from the glaciers. The bright green area here along the coastal area is artificial fill that was laid down to expand area for building. The purple down here is alluvium, which is sediment that comes down rivers and adds up naturally. The tiny neon green areas right down here are intrusive andesite lava, which has been exposed through faulting and erosion. The little pale sandy areas along the beaches are modern beach deposits, and the big green areas here are mixed pre-Fraser and non-glacial deposits. Now, there are two types of slides that mainly happen in the Seattle area: shallow and deep-seated. The shallow landslides are 2 meters or less in depth, and usually an acre or less. The deep-seated slides involve much deeper areas of the sediments. A whole block will rotate 45 to 90 degrees and slide downhill, taking everything above it. And in Oso, actually, it was the shallow type of slide, but because there was such damage to the ecosystem there due to logging and previous sliding, their heavy rain made a shallow mudslide extend very far, much further than it normally would, and destroyed 50 houses and killed 43 people. This is the kind of thing that can happen in these landslides. Glaciation in the Seattle area is similar to the glaciation cycles in the rest of North America. There have been 7 major stages in the last million years, with many minor stages or stades included in them. The Fraser glaciation is what we'll be looking at. That peaked between 23,500 and 21,000 years ago. The Vashon Stade of the Fraser Glaciation ended 13,000 years ago. That's basically the end of the Ice Age for us. It was a very short period, only about 4,000 years, but it left behind a lot of sediments because the glaciers left a lot, the outwash from the melting glaciers left a lot, and on top of what was already there. My data came from the US Census Bureau Tigerline, American Community Survey demographic data, and 2010 total population figures. I acquired digital elevation models from the University of Washington and Washington Department of Ecology slope stability model. This is an early 1900s photo of houses that slid downhill when the base of the hill was removed for other building purposes. So it's really not a good idea to do things like that. My methods were to mosaic 24 DEM tiles together, run the ArcGIS slope calculation tool on them, classified the slope stability model to highlight unstable slopes, join that model with the DEM slope calculation, reclassify to show moderate, high, and dangerous slide likelihood areas. Then I did a proportional calculation of the slide polygons versus census tracts. I then digitized 3,325 houses as points using Google Earth and my slide polygons to find them. The identity tool was run to find which likely areas the houses belong to, as well as which census tracts. Then calculated population in the actual housing units using a mean of 2.97 persons per housing unit based on Seattle population figures. Then I ran a buffer tool to show a 50-meter buffer zone around the slide areas to aid city planners in finding areas that need mitigation. This is my slope stability model on the left and the DEM slope calculation on the right. When you put them together, you get the areas with greatest likelihood of landslides. You can't really see them very well here, but we will blow them up. The proportional calculation predicted housing units in the sample area. I show Alki Point here because it's very, the results are very different in the actual housing from the predictions. The dark areas here and here show up to 789 houses per polygon and up to 2,919 people, between 600 and 2,900 people. But when we go to the actual digitized houses and run it through the identity tool, the actual houses in the biggest polygons only had 141 people, and the smallest were between 1 and 4, and many areas here that were predicted to have many houses had none. This is a house in Alki Point that experienced a slide. The homeowner was lucky. His retaining wall kept the hill behind him from coming completely into his house. Here's a blow-up area of northwest Seattle and west Seattle. You can see some fairly high areas here, little tiny, very dangerous areas there, and on West Point, and further down, there are actually more. We'll see those later. And in West Seattle, around Alki Point, there are quite a lot. Right around here is red for dangerous. And the median home values, based on the census figures, around this area are 591,000 to 680,000. And this lower value area is actually where the most dangerous areas are. Those are 445 to 458,000. Then we come to northwest Seattle. If you can see, there's a long area of red right here and along here. There's no houses in here because that's been prevented building. But these houses here have a mean value of $883,000 to $1 million. And they're right on top of or under a highly dangerous slope. Right here you can see an old slope here, or an old slide here, another one here, right on top of this house right here, and then you have all these houses here and here, right along the dangerous slope. And this is very common throughout Seattle. Another study that was done by Dr. Kate Allstadt of the University of Washington. She got her PhD as a seismologist, and her study focused on the difference between wet and dry conditions in a simulated 7.0 magnitude earthquake to see how many slides there would be. And with dry conditions, she found 5,000 likely landslides. With wet conditions, such as we saw with Oso, up to 30,000 landslides, threatening at least 10,000 buildings. My study area, being much more conservative, only studied the areas 2,000 feet inland from the coast. This is a picture of the Whidbey Island Coupeville landslide. This is a deep-seated landslide. As you can see, the slope is very vegetated. The people in Whidbey Island nearby there heard a big bang, and the slide just completely rotated and went into the ocean. You can see the little house here is this one here, and this house here is this here. But the really interesting to look at is this house here has all of this area. It's probably 50 meters or more between this house and the cliff, and it's what, this one right here. Just a few, not even 10 meters between the house and the cliff now. And this area will then continue probably to regress backwards. So my conclusions are proportional calculation really doesn't work well when mixing scales. So the scales need to be similar. There was a lot of, a huge difference between the predicted housing units and population and the actual housing units. The ground truthing with satellite imagery was the main thing that let me find accurate numbers of housing in each polygon. So a better method for this study would be to combine real estate data, census figures, surveys of dwelling occupants with slide polygons. You actually have to get people on the ground and do surveys. Further study would be to expand the work to Seattle's entire area, perhaps combine it with Kate Allstadt's study to find better damage estimate figures. I need to go back quickly and say that the figures that I calculated with the 729 actual housing units that I found, with the median value in the whole slide polygon area of $714,000, the total for those 729 units would be $521 million. And if you combine that with Kate Allstadt's figures of 10,000 buildings with that same 700,000 figure, you get over $7 billion in possible damages in a 7.0 earthquake in wet periods. So generally speaking, what I'm studying here is landslides that happen without an earthquake in wet periods. But to come up with really good figures, you have to look at the possibility of an earthquake. So to review, we looked at Seattle, we looked at its geology, we talked a little bit about its glaciation, we looked at my data and methods, we showed some results, some very interesting results, and came to some conclusions. These are my citations. And this is a photo of the Woodway landslide in January of 1997. You can see the train tracks at the bottom here. The landslide actually pushed part of a freight train right off the tracks. And a good portion of it is right in the Puget Sound there. So, any questions?